All right, Integrated Math 3 students, we are getting into the next topic for this radical equations unit. So we're going to go ahead and jump right in. All right, so go ahead and in your notes, draw a line. We've learned how to solve radical equations on your Delta Math. You have worked through, or you should have at least seen these first three sections here. There are help videos embedded in that now that I'm a Delta Math Plus member. But I've added, these are my custom made problems, okay? And each of these has one question in it. Now for each question, you're gonna get one attempt, okay? Or excuse me, 10 attempts, excuse me. So this is gonna be different than other radical equations that you've been working on. Like these sections here, they're gonna generate an unlimited amount of problems. However, these will not. So if I show you what this looks like, here we go. Here's the question, this is what we're about to learn. You get 10 tries at getting this correct, okay? Instead of working a ton of questions, you have to make sure that you get this problem, okay? This exact problem. This is one that I created, okay? So there's not going to be tons of examples that look just like this for practice. So that's the only downside to this, is you don't have as much variety of problems. But this is the best that I could do in the situation, okay? So there's 7 questions that are going to be dealing with these higher roots. So that's a topic we're covering today. Also, radical equations with rational exponents. We're doing that today as well. So let's go ahead and get things started. I'm gonna some background music. So radical equations with higher roots. We're gonna go ahead and look at the first example. Let me pull up my sheet here. Let's just start with something very simple. So if I want example 1 here, if I want a cube root, which you guys should remember from last year, what a cube root is and how it works. Cube root of x is equal to 2. Okay, so I'm going to pause the video and I want you to find the value of x that makes that true. Okay, so now you've had a chance to solve it. What you should have gotten here is 8. Okay, you should have gotten 8. So we are still thinking in that mindset of inverse operations. We're using those steps that we wrote down last time. We want to isolate the radical, and then we want to raise it to the appropriate power. So the appropriate power for the last section was squaring it. But since we have a cube root here, we want to cube this. Okay, oops. We want to cube this. So cubed. So now when we cube, my thing is acting crazy today. It gets rid of that root, and we end up with x equals 8. So that's how we would do that. Now, do we need to check this? Well, let's talk about that a little bit. So, gosh, sensitive today. So if I want to check this, I swear this thing is being so strange. If I do a cube root of 8, I want to show that that's equal to 2. Well, hopefully everybody knows how to get a cube root on their calculator. Let me pull up my calculator. So if you're using an Inspire, what you would do is you would press Control, and then you're going to hit this caret button, and you can type in the 3 and then the 8, hit enter, and you get 2. And then if you're using the TI-80 series, which I know a lot of you are, you have to hit the math button. So that's a button on the far left side, and you'll see an option that shows like this right here, right? It has that. That's a cube root. So you'd put in 8 and you'd hit enter, and it should give it to you. So this is confirmed. Now, let me go ahead and tell you a little secret or a little rule for this. Now, checking it's going to be very important. I've harped on that like crazy for you guys to make sure that you are, checking your problems as you're working through them. However, because we're going to work another example, but on cube roots, you do not have to check the work. Okay, we did it here, and if you're just for good habit's sake, you want to do that, I would recommend that. Just making sure that you are checking it. I'm going to restart this pad. It's acting. Okay, so you don't have to check for these cube roots. So let's write that rule. Cube roots yeah, this thing's about to wear me out. Do not need to be checked. I don't know what's happening with this thing, man. Alright, I gotta pause this. I gotta try to fix this. Alright, so here's what you need to write. Cube root equations do not need to be checked. Now, if you feel like you're gonna forget to differentiate between the two, then you can, you know, obviously, you can keep checking them, that's fine. I'm using my mouse, by the way. So let's write example 2. What you're gonna notice on example 2, it's gonna look exactly like example 1. We get, I wanna do -2. And this is just to drive home the point of checking it. So we're gonna solve it the same way. We're gonna cube it. And what happens when we cube a negative? So we're gonna put in parentheses -2. We're gonna raise it to the third power. It's -2 times -2 times -2. That's going to give us -8, okay? So x equals -8. And we can trust that answer. So this is one of the reasons why when you're checking, because when I plug in a negative, let's write that in red. When I plug in a negative underneath a root, remember with square roots, we can't plug in negatives. But for cube roots, you're actually allowed to do it, okay? So for cube roots, you can plug in negatives. And I think you would have learned that last year. I'm pretty sure that, or at some point you have seen that, okay? So we know this is -2 equals -2 if we're checking it. Now let's try this with another higher power. Example 3. Let's say we want a 4th root, okay? So now we have an even root, and we're gonna do the same exact thing. So what do I need to do to get rid of this cube or 4th root? Well, I want to raise it to the 4th. You do that over here as well. So we get x equals, what is -2 to the 4th? Well, that's gonna be +16. And we can confirm that. Make sure you use parentheses. You have to use parentheses for raising things to powers. +16. Okay, so now when we get +16, we can't use this rule up here for this, because this is a 4th root. So you're going to notice if we check this and plug it in, so we're going to put 16, 4th root of 16, is that equal to -2? Well, let's go ahead and try that. So 4th root, for those using the 80 series, if you were typing this in, you have to go to the one below the cube root and type in your power. You may need to watch a video on how to do that. So let's put a 16 in here, and we're gonna get +2. Okay, so this is 2 equals -2, which is not true. So this would be extraneous. So really the rule should be this. Instead of it being cube roots, really the rule is odd roots. Okay, so if you want to go back and adjust that, hopefully you're not using pen, go back up there. Odd roots, odd root equations. I shouldn't even say roots. Odd root equations do not need to be checked. So if it's an odd root, like a 5th root, 7th root, you don't have to check your solutions. But they're even, you need to absolutely check them. Just to be safe, you could just always check them, okay? Let's look at some examples that are a little more complex. These won't get too complicated just because sometimes when you have cube roots, it can get pretty intense, like the size of the numbers that you're gonna get. So this is example, what is this, 4? Okay, so example 4, I'm gonna go ahead and write it up. So again, I'm writing with my mouse. So I'm gonna go ahead and pause this and give you a chance to solve it. So see if you can get the answer. Let's figure out what x is equal to. All right, so you've had a chance to solve it. You should have started by cubing. And when you cube the 5, you should be, this goes away over here, so it's x minus 3. And then you should get over here 5 to the third, 5 times 5 times 5, that's 125. So we're gonna add the 3. That gets us 128. Okay. All right, so that's gonna be our answer. Do we need to check it? I've said that we don't because it's an odd power. We can trust these answers. They're not gonna be extraneous for odd powers, okay? But of course, if we plug it in, we know it will work, okay? Let's do another one. Let me find what I want here. I'm just gonna make one up. Example 5. So we're gonna do cube root. We want 2x plus 7 equals cube root of 3x minus, let's say 8. There we go. And let me make that a negative 3x. There we go, negative 3x minus 8. Okay, go ahead and I'm gonna pause. You guys can try to answer this. Okay, so you you had a chance to solve this. The first thing you should have done here is cube both sides. And you'll notice that when you do that, when you do that, it gets rid of both of them. And now we just have a very simple linear equation here. And you get to pick how you want to solve it. Try the pad again. So what I would probably do is add 3x to both sides. I would get rid of this, and then I'm going to subtract 7 from both sides. So this gets me 5x equals, these go away, 5x equals negative 15. Then I'm going to divide by 5. This goes away, we get x equals negative 3. We're going to do one more example. So let's do example 6. 3 plus cube root 4x minus 8 equals 1. Okay, go ahead and try to solve that. All right, so you're gonna notice that you should have started by moving this 3 over. I need to take this pad in and charge it. I'm done trying to use it. It's unfortunate. This is gonna cancel out. We get cube root of 4x minus 8 equals negative 2. Then we need to cube both sides. That gets us negative 8 here. This is 4x minus 8. And we're just gonna go ahead and solve this. We're gonna add 8. We get 4x equals 0. Divide by 4. 0 divided by anything is 0. Okay. So that's gonna be our answer. If we plug that in and check it, it would still work because we can take square root of negative. So this is good. Okay, so that is radicals with higher powers. You should be able to answer all these questions. There's not too many more intense examples on here than what you see. Yeah, nothing too complex. There's a 4th root right there. 3rd root. Yeah. Nothing too extreme. If you have any questions about problems you're having trouble getting them, then just send me an email of which one it is that you're working on, and I can help you individually make a little video for you, okay? All right, we're gonna move on to the next topic. We're 15 minutes in here. We're gonna get radical. Let me just pause this so that y'all don't have to watch me write it. Radical equations with rational exponents. So what are we talking about when we say the word rational and the word exponents? Well, exponents should make you think of powers, right? So for example, if we have x raised to some sort of power, I'm going to want you to write this with me. We're raising it to some sort of power up here, right? Okay, well, what does that power have to look like? Well, what does rational mean? We just finished rational expressions last unit. Well, rational expressions rational means a fraction. So we have a fraction, and I'm going to write something that you should have seen last year. Okay, x to the m over n. This was like the general format, and with that we could convert it. You did this last year. You had, like, on a test, you had to do this in iMath 2, and it looked like something like this. Okay, you have x to the m over n is equal to the nth root of x to the m. So an example would have been, if I wanted to, let's do a cube root of x to the 8th was equal to, and you had to do this last year, and I'm at to it was like multiple choice probably. You had to pick the one that converted, so it was 8 over 3, right? That's how you had to do that. That's not what we're learning, but it's going to help us to remember that and understand it. For instance, if we have a square root of x, what is that power going to be? Well, what's the number in front of this x right here? A lot of people think that it's a 1, but it's actually not a 1. It's because usually in math, when you don't see a value there, you're always automatically thinking, oh, it's got to be a 1. In this case, this is one of the single cases where it's not a 1. It's actually a 2, and that's why we call this a square root, is because, yeah, it's implied that there's a 2 there. Inside, what's this power? Well, that is a 1. So if we're writing it as a rational exponent, it's 1 over 2. So when I square root something, if I'm taking the square root of something, it's the same as raising it to a half power. So if I asked you, what's 9 to the 1/2 power? You should say, oh, it's 3, because that's equivalent to square rooting it. Okay, that's an equivalent way to write a radical. It's a very important rule for you guys to remember when you're preparing for, like, say, ACT and things like that. It's super important to know what those exponents mean. So with that in mind, what would a cube root be? Cube root of x. Cube root of x should be 1/3, right? Now we're not going to go much further than this, but what is a 4th root? Well, that should be to the 1/4. So those are things to keep in mind, and we could say ... It would keep going in that same pattern. But this is what we're mainly going to be using in the half roots and 3rd roots, okay? So let me get us an example here to work for this. Let's do, so example 1, and I'm going to go ahead and write it up. I'll pause so I can write it. All right, there's our problem. So go ahead and try to get x. Let's solve for x. You should be using the exact same steps that you were using, okay, from the last part. All right, so you've had a chance to answer it. And when you're looking at this, we have to do the same thing. So the first thing was to isolate the radical. So I have some students that like to do this. I'm going to erase this so you don't have to write it, but just check out what I've seen some students do is they've gone ahead and rewrote it like this. And if you like that approach, like if you say, okay, I know 1/2 means a square root, you can go ahead and change its form and then solve it just like we've been doing, okay? But we don't have to do that, okay? So I'm not going to. We want to get this 1/2 by itself. So I'm going to divide both sides by 7. So 35 over 7 is 5. which equals 4 7x. Now, this 1/2 power, we have to think, well, what do we do to that? Well, if it were the square root, we would square both sides. And actually, that is exactly what we want to do, is we want to raise both sides to the 2nd power. That's what we want to do. So you always raise it to its reciprocal. Hopefully you remember what a reciprocal is. If I have 1/2, the reciprocal is 2/1. And what happens when you multiply by the reciprocal is it makes the fraction go away. Okay, so maybe that's something you've seen before. So when we square this, these cancel out, or they divide each other out. So this is 4 minus 7x. Here, 5 squared is 125. Okay, so now we finish solving this. We're going to subtract 4 from both sides. That gets us 121 equals negative 7x. All right, then we need to divide by negative 7. This goes away, and I need to know what is 121 divided by 7. We'll make that negative. So does that not divide evenly? Did I mess something up here? Hold on. Minus 21 divided by 7. Hold on one second. Yeah, I messed up something real bad. So I see that this should just be 25, which makes this 21. I'm sure y'all are seeing that at home. So this is negative 3 equals x. Now we do have to check this, okay? Because this is an even power, technically, an even root over 2, I need to check this to make sure that it's valid. There are problems that will occur to where you're gonna, if you don't check, you're gonna get it wrong. So we've written it up, we're checking it. 35 is just gonna stay 35 the whole way. This is 7 square root. This is gonna be 4 plus 21, which equals 7. Man, I miss writing with that Moby pad. 25. This is 7 times 5. So that equals 35 equals 35. So that one actually works. Check. Okay. So that's just our first example. That's how we're dealing with these rational exponents. Okay. Let's go ahead and do another example. All right, so I've written up example 2 here. I'm gonna go ahead and pause it, and I'd like you to work it. This, by the way, is a 3. Let me just make sure that that's there. Okay, 3x to the 1/3 plus 3 equals 5. Sorry, this is actually supposed to be a 6. So go ahead and work this problem. So you've had a chance to work it. What you'd want to do here is start by isolating this x to the 1/3. We want to always get that by itself. So we're going to move the 3 over, trying to solve for x here. That's going to get us 3x to the 1/3 equals 3. We're going to divide away the 3. We get x to the 1/3 equals 1. And then we're going to raise it to the appropriate power. What power should we raise it to? Well, it's 1/3. We want to raise it to the reciprocal of that, so that's cube. We want to cube both sides. So x equals 1. Okay, and that's how we solve that. Now, you might have been able to deduce that just by reading the question to start. But again, we're just trying to practice these processes for solving with rational exponents. So I think most of us have the core idea down. Of course, if you wanted to change that x to the 1/3 to cube root of x, then it's no different than the examples we worked before we got to this section in our notes, okay? And I'm gonna go ahead and stop the lesson there. You have lots of examples here that you can work on, 8 examples. This is what they're looking like if you wanna just sort of glance at them a little bit. Some of them end up to where you're solving quadratics, okay? I would do a few more examples, but my wrist is getting tired of writing with this mouse. I think I need to charge that Moby pad. So I'm gonna go ahead and stop the video here and make sure that you start working on these and ask me questions if you have them.